A couple of days ago, before we performed our acceleration lab yesterday, we took a look at the last thing that we really have to do before our mid-unit test, and that was acceleration due to gravity. We established that every object that falls, in the absence of air resistance, every object that falls or rises will accelerate at the same rate. That rate of acceleration will be, regardless of whether it's going up or down, negative 9.81 meters per second squared. Okay. That's not how fast it's going. We don't want to say that's its speed. That's not its velocity. That's its acceleration. That's how fast the speed is changing by. We know it's 9.81 meters per second squared because it's caused by the Earth, regardless of whether it's going up or down. But what about negative? Why is it negative 9.81 when it's accelerating downward? Well, okay, because it is going downwards, but it's speeding up, or it's accelerating in the negative direction as it goes downwards. But what about when it's going upwards? Why is it negative 9.81 as it's going upwards? 9.81 because it's caused by the same thing, caused by the same Earth, whether you're going up or down. But what about the negative there, Mackenzie? Good. As it's going upwards in the positive direction, it's slowing down, it's decelerating. So you got to have a negative in there somewhere. In the case of it moving downward, it's a positive acceleration in a sense, right? It's speeding up, but it's a negative direction. We make it a negative 9.81. As it's going upwards, it's a positive direction, but it's a slowing down thing, a negative acceleration. So in either case, we're going to make it negative 9.81 meters per second squared. All of our group B equations and all those acceleration equations still apply. But now when we're solving a problem, we have an extra given. In all of our problems, we know that A will be negative 9.81 meters per second squared. So it's one more piece of information. Theoretically, it should be easier, right? Because we don't have to read between the lines for some things anymore. We have the acceleration for all the questions. Okay, we had a few questions that we worked on Monday, and this was the first set that we worked on, page 58. Any issues with any of those questions, 1 or 2, on page 58? Okay? What about the last set that you had for homework, which involved only the one question on page 59? Need to go over that one? Yes? Okay. Okay, let's look at it then. It says a slingshot drops riders 27 meters from rest before slowing them down to a stop. How fast are they moving before they start slowing down? Mathematically, this isn't any trickier than any other questions we've done, but reading the question and interpreting the question, it is a bit trickier, I think. Okay, I think this is a bit of a challenge, this question. It drops riders 27 meters, and then it slows them down. So you're free falling for stage 1 at 9.81 meters per second squared, and then during stage 2, this slingshot begins to slow the riders down. So I don't know what the acceleration is there, right? You're still falling, but you're not under the influence of just gravity in stage 2. We want to know how fast they're moving before they start slowing down. In other words, we want to know how fast they're moving right here. Probably the way to handle this is to deal with only the first part of the problem. This. Don't worry about as they slow down. Okay, that's another problem. That's an important problem. Okay, if you're the engineer that's designing this ride, then you're going to want to analyze the part of the problem where they're slowing down. But for us right now, all we want to do is deal with as it falls, the free fall portion of it. So if that's the case, we're going to say VI is equal to, it drops riders. Doesn't throw them, it drops them. VI would be equal to 0 meters per second. What do we got here? A is neg 9.81 meters per second squared. Anything else there? What's the 27 there, Zach? Displacement. We're going to make it negative 27 though because it falls. Now, technically, we could make that positive, but if we did, then we'd have to make acceleration positive as well, and then that's going to get confusing. Okay? We get in the habit of always making gravitational acceleration negative 9.81. Let's just always make down negative. Therefore, that should be a negative 27. What else? What are we looking for? Cody, what are we looking for? Yeah. Good. VF is the unknown. So we got VI, we got D, we're looking for VF, got A. What do you want to try here? Yeah, right? No. Okay, good question, but it wouldn't be 0. Cody, do you want to address that? Hold on. Okay, hold on. We're going to answer his question first. I know, you get excited about answering the first question, right? No, Mackenzie, that's a good question. I'm glad you asked it. So wouldn't it be 0? Wouldn't the final velocity be 0 because it slows down to a stop? Okay, at the end of the second problem, VF would be 0, right? But look at what we're analyzing. Okay, it falls, it free falls, and then it does something else. Remember we saw those problems earlier where the word then appeared? The word then doesn't literally appear in this question, right? But it's like it does. This happens, and then something else happens. Okay, if we wanted to analyze this section, we'll call it the green section, section 2, as it's slowing down, then the final velocity would absolutely be 0. And the initial velocity would be whatever the final velocity for the first stage is. All we want to get, though, is the final velocity for the first stage. How fast is it moving before they start slowing down, not after they stop? It's kind of like, who was it? I think it was Anthony that we did the little demonstration with the hole puncher with, was it? Yeah. Obviously we weren't going to drop the hole puncher on him, but the idea was if we drop the hole puncher, it's going to hurt, right? Why is it going to hurt? Because when it hits him, it's moving. Now, then it slows down as it hits him and stops, right? But at the moment it hits him, it hasn't slowed down yet. So it's still moving. Okay. That's kind of what we got here, except it's slowing down in a more deliberate fashion in the second stage here. All right, so we got VI, got D, got A, looking for VF. What do you want to try here? What equation? Tell me what equation we can't use. Nolan, which one can't we use? Which one are we absolutely not allowed to use? Not which one doesn't seem to work very well here. Which one are we not allowed to even try? No, that's an acceleration equation, right? We're allowed to try that. Which one are we not allowed to try here? Good, V equals D over T. Why can't we, Nolan, listen to this. Why can't we use V is equal to D over T? Because that's a group A equation, right? And this is acceleration. It's speeding up, right? So we're allowed to use the acceleration ones, not the group A, not V equals D over T. Guys, I'm going to try this one, I think. Actually, Cody, you were going to give me an answer for that. Which one? Good. That's exactly what I would try as well, because of the givens that I have, right? Solving for VF. VF ends up being the square root of VI squared plus 2AD. Now, VI is 0, so that's nice. 0 plus 2 times neg 9.81 times the displacement of negative 27. Do the math on that one, it should work out to be 23 meters per second. Now, what have we just solved for? What have we just solved for? The final, nope. What did we just solve for? Final speed. What were we looking for? Well, I wrote down that we were looking for final velocity, but we weren't really, right? It says, how fast are they moving? Okay, that's a speed, right? So we actually got right here what we were looking for. Now, if it had said, what is the final velocity? We would have still solved for it this way, got 23, and then we would have just said 23 down, or stuck a negative in front of it to indicate that it was down. Okay, we don't need to do that here, though, because we're looking for speed. Got it? Okay, I got one more for you, and that's it for the day. A clown throws a ball upward at 10 meters per second. Wait, this sounds a lot like the last example problem we had. Clown throws the ball upward at 10 meters per second. This time we're solving for something different. It says, find the time it takes for the ball to return to the crowd's hand from the maximum height and find the ball's final velocity. The time that it takes the ball to return to the crowd's hand, so the ball goes up, leaving with an initial velocity of 10 meters per second. It goes up. What's the velocity rate here? 0. It stops, right? And then it comes back down. I can answer B right now. If you start at 10 and you slow down at a rate of 9.81 and you stop, and then you speed up at a rate of 9.81 over the same distance as you slow down at, what's the final speed going to be? 10. Same speed you started with, right? If you speed up at the same rate you slow down over the same distance, the final speed's got to be the same as the initial. So I'm going to say VF would technically be negative 10 meters per second squared. The time that it takes, I'm probably going to say A is equal to delta V over delta T. The final velocity as it reaches the ground is negative 10, not 0, right, Anthony? Yep. Negative 10 as it hits the ground, negative 10. 0 would be the initial velocity, right? We're looking for the time that it takes from the maximum height where it's moving at 0 meters per second. Solving for A, right? So let's rearrange this, actually. Thoda's question? Good? Yeah. Okay. So final is, what do we say, neg 10 minus 0 over the acceleration of neg 9.81. So we're going to get something like 1.02, I think it is, isn't it? Positive 1.02 seconds. 1.02? Should technically be 3 digits. So this should technically actually be 10.0, right? No, actually, oh, wait a second. A little bit of a sig fig trick here. This one should be 1.02 because we used 9.81, right? We used 10.00 and 9.81. This one should actually be 10.00. How come not 3 digits there? We didn't use 9.81 for this, did we? We just said, oh, look, if it started at 10.00, goes up and stops, comes back down, it's got to end up at 10.00. So that one technically should be 4 significant digits. To tell you what, if you ever put that, you ever put 3 digits on that because you ever think in gravity 9.81, I wouldn't mark that wrong, even though technically it is. Yep. See what you can do with this question, guys. If you finish it in class, great. If not, let's finish it up for homework tonight.